All right, welcome everyone. This is the Science of Clouds. So like I mentioned, this is our last series, or the last episode, I guess, in the series for today. So we're going to go ahead and get started. I'm going to share my screen. Maybe like 5 buttons just got pushed at once. What's going on? Okay, here we go. All right. All right. So like I mentioned, welcome everyone. This is the Science of Clouds. We're going to be talking about not necessarily how they deal with animals or wildlife or anything about that. We're just talking about clouds today. So also, if you have questions or comments, I hope that you do. Please go ahead and put them in the chat as I'm talking. I do have some kind of breaking points in between certain topics that we're going to talk about today where we can look and see on questions. And then also at the very end, we will do like a question and answer session as well. So if you don't have questions, that's totally fine. And if you do, please put them in the chat. While you're putting stuff in the chat, just make sure that we are staying on topic and that we're relevant and that we are all being kind to each other. All right, and also just want to point out, I am by no means a cloud expert or anything associated with weather. This one, I learned a lot of information doing this for you and doing the research for you. So I have kind of like been noticing the last few days, I was like, oh, I know that type of cloud now. So it does work and I do kind of understand what's going on. So, but like I mentioned, if I have a question or if you have a question for me that I can't understand, I will find someone that can, and I will get back to you as well. So. All right. So I thought we could do just a very brief introduction on what a cloud is. There's a lot of speculation, and even I remember in science class when I was little, I would like wonder what clouds are and how they formed, and I never really remember a great answer. So I want to make sure that we bust any of those myths that we maybe have, or guide your right information to those misconceptions that we may have about what is a cloud and how they're formed. So, so what is a cloud? I've heard a lot of people say this before, that they are just water vapor. So that's not true, because otherwise we couldn't see them. So the air around us basically is partially made up of invisible water vapor, but what happens is the water vapor will actually cool as you go farther up into the air or to the atmosphere, and it condenses into something called liquid or water droplets, basically, or solid ice or crystals, and that's how clouds form. So basically it's water droplets or ice crystals that are floating in the sky, and what happens is, like I mentioned, the air gets cooler the farther you travel upward, and then that water vapor is condensed into the sky and it sticks to things. So things like ice or sea salt, if it's over like the ocean or something like that, and then also bits of dust. So that is what we are seeing. Those are the clouds. And then it's just the way that they're formed in the atmosphere makes them different types of clouds. We'll talk in a little bit about the 3 major types of clouds, but it's their altitude really determines the shape of them, and then what also happens with those clouds, or the weather that is associated with those clouds. So also, a lot of people have asked, do clouds weigh anything? They do. So they weigh a certain amount, but it's all dependent on the type of cloud, and like I mentioned, where it is in that altitude or the atmosphere. So when we're talking about like an average, what we call a fair weather cloud, so nice weather, a fair weather cloud without rain or without ice, it weighs about 1.1 million pounds. So thinking about a cloud sitting above us that weighs that much, and it's not falling into us or falling on us or anything like that. So how do they know how much clouds weigh? They have a very good guesstimate. Basically, they multiply the density by the volume of the element. So that is how scientists and people who study clouds, that's what they kind of get to. So that's the formula that they use. So that's kind of like what a cloud is. We see clouds a lot and we see different colors. So why are they white? Why are they gray? So clouds usually appear white to us because the tiny water droplets inside them, they're very packed together, and it reflects off the sunlight, or the sunlight reflects off of them. So basically it's all how our eyes perceive the wavelengths and the color of sunlight that are all mixed together. So when it's about to rain, the clouds will darken because the water vapor is clumping together into raindrops, and there's larger spaces between the drops of water. So that's why less light then is reflected, and so we start to see a different color. So we might see rain clouds as dark gray or sometimes black even. So it's all basically our eyes and how we perceive them and what's happening as far as the spaces in between those raindrops and in between the water vapor up in the atmosphere. All right, so really quick, how do clouds form? Well, they form when air becomes saturated or filled with water vapor. So warm air can hold more water vapor than cold air. So the lowering of the temperature of an air mass is like kind of like squeezing a sponge. So the squeezing that you would do, the clouds are that visible result of the squeeze of that cooler, moist air. And then the moist air becomes cloudy with only slight cooling. And then with further cooling, the water, the ice particles that make up that cloud, they can grow bigger and bigger and bigger, and then the particles then will fall to earth as precipitation. So that could be snow, that could be hail, that could be rain. And what we will learn later too is that not all clouds mean some type of precipitation. So sometimes they are just clouds. They don't carry that rain or snow or anything like that. And it all depends on the temperature, and it depends on the atmosphere, and it also depends on the altitude that the clouds are. So there's a lot of formulas that go into making that precipitation and what those clouds are going to look like and how they're formed. We will go through the different types of clouds, and not all clouds are formed the same way. So we will learn that. All right, so that was like a very basic what a cloud is, what we're seeing in their atmosphere. So let's talk about the different types of clouds. So we've all seen and looked up and seen big white puffy clouds or kind of tufts of clouds. So if you look at this photo, there's lots of different types just in that photo. So and clouds can change as they would move up, as the weather cools, as it gets warmer, as they get heavier. So everything's going to just be based on that. And also they can change over time. So when we talk about types of clouds, there are three main groups that we're going to look at, and it all is dependent on where they are in the altitude range. So there's something called high clouds, which are going to be way above us, 16,500, about 45,000 feet in the air. So these are ones that you're only going to see when you're flying, and also those mid-level clouds as well, just depending on where you are. But those mid-level clouds and about 6,500 to 23,000 feet in the air. And then the low clouds, which are we associate as like the storm clouds, those are going to be less than 6,500 feet in the atmosphere. And then also the classification of cloud types was first proposed in 1803 by a person who was an amateur meteorologist. He really liked this and he just kind of studied it. So it's based on a book written by a London pharmacist. So basically what he did was he studied clouds and amateurly, and he figured out that there's these different levels of clouds. So the terms that he uses are still readily acceptable, but they have been added to. So in the modern era, we have added to them. There's about 10 different types now that fall in between the mid, the high, and the low level clouds. But a lot of the meteorological community still uses these examples and these words and vocabulary that he used then. So types of clouds. So, and then the groups of clouds. So clouds, like I mentioned, they're continuously changing and they appear in a variety of forms. It just all depends on, like I mentioned earlier, the how heavy they are, how warm it is. There's a lot of factors that go into play there. But the World Meteorological Organization, or the WMO, has extended this guy Howard's classification. So he came up with those three basic cloud types, and I mentioned earlier they extended it. So this is kind of what they use now. It's very similar to what he had back then, but it's divided into three levels. Sometimes you will see them as a CL, CM, or CH. So CL is a low cloud, or a cloud that's low, cloud medium, or cloud high. So this relates to the part of the atmosphere in which they are usually found. All right, so also what you will notice is there's a lot of long words that are coming, and you're going to hear stratus and cirrus and alto and nimbus, and it's like, what do those mean? So most of the names of the clouds come from Latin, which a lot of all scientific classifications come through that. So it's a combination of these prefixes and suffixes, and I just wanted to make sure that people understand what I'm saying when I say stratus or cumulus. So stratus, any type of stratus cloud, like Stratocumulus clouds, are going to be doubled on there. So stratus is simply like a flat layer or smooth cloud. Cumulus is going to be like puffy, like a cauliflower. That they like cauliflowers, and that's how a lot of this meteorological community kind of describes things. So cauliflower-like. And then you might also hear something called a cirrus, so high up or like this wispy cloud. And then alto, very much like when you're singing to those different levels, you'll hear a medium level. And then a nimbus cloud means a rain-bearing cloud. So as we go along today, you will hear some of these, and some of them might be combined, like a Altocumulus cloud. So it's going to be a medium level, puffy, cauliflower-like cloud. So just so that everyone kind of understands where these are coming from and why we're using them. All right, so we're going to start with the very high clouds, the ones that maybe you will never see unless you are in an airplane, or if you watch TV and you watch like a NASA space launch or something. These are the ones that you're going to see way up in the sky. So here's kind of a cool diagram that I found that kind of shows the high level, the medium level, and then those low level clouds. So I will be referring to a lot of these, but this is kind of a cool diagram that kind of shows the different shapes, the different kinds, and where they are located in the atmosphere. I will reference this many times, but I just wanted to show you to start here. So we're going to be starting at the very highest level up here where it says like the cirrus and the cirrostratus and the cirrocumulus. So that will be kind of where we are starting today. All right, so cirrus clouds. So these are these kind of like wispy looking clouds that you see that don't necessarily look like clouds, really. They look like a smoke trail or something like that. But all when we call high clouds are a type of cirrus. So cirrus is almost like a blanket or an umbrella term. It's a very common cloud that can be seen any time of the year, but they're very short, they're detached, they're hair-like structures found at very high altitudes. They're very delicate clouds. They kind of look like a silky sheen or like a tuft of hair. And then usually in the daytime, they're going to be whiter than any other cloud in the sky. And then while the sun is setting or rising, they may take on the colors of that sunset or that sunrise. So they form because of the ascent of dry air. And then, like I mentioned, the ascent, so it goes up, that dry air kind of forms these wispy looking clouds, and they make the very small quantity of water vapor in the air undergo a transition basically into ice. So these are our cirrus clouds. So how do they form? Like I mentioned, cirrus is made up completely of ice crystals, which provides them their white color, and they form in a very wide range of shapes and sizes. Again, very high level clouds. They can also form through contrails, which is if you've ever gone on a plane, you know that the jet fuel will get burned off into the atmosphere, not chemtrails, contrails, vapor trails left by planes as they fly through the upper, what's called the troposphere. So this is what we're seeing, and they often form in advance of a warm front. So we're going to be talking a lot today about what do clouds mean. They're not just up there to see shapes in them, but they do mean weather, and sometimes it could mean a significant change, or sometimes in case of this one, it usually is in advance of a warm front coming in. The streaks can also spread out when we're talking about these contrails, that they become either cirrus or Cirrostratus or Cirrocumulus clouds, but they're again very high in the atmosphere. And technically these clouds can produce precipitation, but we will never see it because it never reaches the ground. So technically they do, but we will never see that happen. All right, and then one thing you might see are these things called virga clouds. I did not know what they were called, but I have seen these clouds many times. Oftentimes when you see a storm or you look way in the distance, you're like, oh, it's raining over there, because you see these like streaks. So this basically is a type of cloud. It's precipitation that evaporates in the air before it ever reaches the ground. So it does come down, but we never see it. It evaporates too quickly. The air masses meet at very high levels, indicating a change in the weather is on the way. They can be found in lots of different cloud types, about 7 of the 10 that we're going to talk about today. And then when you translate virga in Latin, it means rod or rod-like cloud. It's created basically when precipitation drops from a cloud, passes through a layer of dry air, and then evaporates right away. Instead of re-evaporating those cirrus clouds, they can make these Virgus clouds or Virga clouds. And then when rain falls again, but it doesn't reach the atmosphere, or it doesn't reach the ground. All right, so within each cloud type, there's like 5 other species of clouds. We're not going to spend too much time into them, but when you're looking at them, they will all have the same prefix, so that's cirrus. And then the second one, the suffix, will kind of talk about what that means. So there's cirrus fibratus, so very white parallel stripes. It's a very common type of cirrus cloud. Or cirrus flocus, so having a more cotton or wool-like appearance. So there's a lot of different types of clouds. We're kind of going to focus on the main types today, but I do want you to know that there's lots of different what they call species or genre of clouds. So we will mention them, but we're not going to spend a ton of time on them today. I can put in a link in the registration. All those that registered will get an email from me tomorrow, and I can give you the links if you're very interested in seeing what these look like and looking more into those as well. All right, so now we're going to move into the Cirrocumulus clouds. So these are relatively rare, but they form these ripples, which kind of resemble a honeycomb. I'm sure many of us have seen them before. So basically, they're clouds that are made of lots of smaller clouds called cloudlets, which are grouped together at very high levels. They're formed almost entirely of ice crystals, and those little cloudlets are regularly spaced across, and they look, like I mentioned, like ripples in the sky. Sometimes people have known them to be what's called the mackerel sky, because it reminds a lot of people of the skin of a fish or the scales on a fish. So sometimes if you hear someone call it a mackerel sky, these are the type of clouds they're referring to, those cirrocumulus clouds. All right, so how do these form? They're made of both ice and what's called super cooled water. So very cold water. They form when the turbulent vertical currents meet a cirrus layer, that's supposed to be layer, creating the puffy cumulus shape. So that's what gets them the kind of puffy, like mackerel look or appearance about them. It remains a liquid even at a very low temperature, even at 0 degrees Celsius. So very cold, it still remains a liquid, and that's how we get these. These clouds can also form through those contrails that we talked about. Lots of different types. We mentioned 7 of them can form through contrails. But then precipitation from these clouds, again, they're so high, it never reaches the ground, but it is associated with a fair weather. So if you see these, it doesn't necessarily mean a storm's coming. And then appearance can often prelude stormy weather, but not always. It depends. All right, so then within these Cirrocumulus clouds, we have 4 defined species. So Cirrocumulus stratiformis, these flat or sheet-like patches with fish scale-like appearance. Or you have these lens-shaped clouds with almost like a rounded shape. Or you have fluffy tufts, which more rugged in appearance. You have taller than wide clouds that look like tiny towers in the sky. So again, lots of different types of clouds. All right, so Cirrostratus clouds. These are very thin. They're layered cirrostratus cloud that's composed of ice crystals, and they form this cool veil that covers most of the sky when we look at them. They can be smooth, or they can be what's called fibrous clouds, and they're often fringed with something called a cirrus cloud. So they're kind of combined almost together. The shadows that normally form when the sun is shining through these clouds, we can often distinguish them from what's called the Altostratus Clouds. But these guys, sometimes they produce white or colored rings. Sometimes they're known as like the halo effect, if you've ever heard of that. But spots or arcs of light around the sun or moon. So you might have heard of those before. They're very transparent, high clouds, like I mentioned, that cover a large portion of the sky. And then sometimes they're so thin that halo is the only indication that a cirrostratus cloud is in the sky. So if you see that halo phenomena, you know that a cirrostratus cloud is around. All right, so how do these form? They can span thousands of miles. They're huge clouds. Remember I talked about how they look like they just cover the entire sky like a blanket. The shadows, like I mentioned earlier, they're cast when shining through the Cirrostratus Clouds. And then as a result of that slowly rising air, this is how that they're formed. Usually generated at the forefront of like frontal weather systems. And these clouds are actually used to predict what the weather will do in the next 24 hours. So and again, these can also form through contrails. They won't necessarily be as big, but they can form over time with these as well. And then this type of cloud does not produce precipitation directly, but it can indicate whether or not precipitation is likely to happen. So if you see the Cirrostratus vibratus, it's spotted stratus cloud, it basically will just bring a light drizzle, nothing that we should really be concerned of. And then the two types of Cirrostratus clouds, you have these wispy strings, or then you have this uniform veil-like covering in the sky, that nebulosus. All right, so those were our high clouds. Now we're going to come down a little bit in the atmosphere. So these are going to be the medium cloud types that we're going to talk about. So here's where we are in the atmosphere right now. We're going to be talking about these like Altocumulus, Altostratus Clouds. We're coming down into the atmosphere, so they're going to get a little bit more dense. They're going to start making some precipitation, and also the weather is going to be different that's associated with these clouds. All right, so first one we're going to talk about is these Altocumulus clouds. These have a ton of varieties with them, but generally they're clouds that are associated with settled weather and normally appear white or gray, sometimes depending on that shading. They're very small mid-level layers or patches of clouds, which most commonly exist in the shape of these like rounded clumps. Like I mentioned, there's many varieties of them, but they're made up of a mix of ice and water, and they give this kind of like ethereal look or appearance to them, rather than those like big fluffy lower level clouds that we'll talk about in a little bit here. But they're mostly found in settled weather, usually composed of droplets, but also contain ice crystals. And then with these precipitation is rare, but also can be seen in the form of those virga clouds that we mentioned earlier, where like the streaks where they evaporate into the air before it even comes down to the ground level. Those are some of the same types that can form with these Altocumulus as well. All right, so how do they form? They form in several different ways. Basically, if you have an altostratus and it breaks up, it can form these Altocumulus clouds. It also can be formed by the lifting of the air pockets, which are cooled, but then gentle turbulence kind of hits them, and then they can also form these Altocumulus clouds. And then another way is sometimes in mountainous areas, that mountainous terrain, it can produce very interesting atmospheric, what we call waves. And then clouds can form based on that rugged mountainous terrain because of that high difference in altitude. Sometimes the presence of shading can kind of help distinguish between an Altocumulus and a Cirrocumulus. I am not one to ask how you would tell that in the atmosphere or look at those. My guess is that you would need a lot of practice, but if you are very good at that, I guess the shading can help with that as well. And then also those Cirrocumulus clouds are very white and tiny, but Altocumulus clouds can be white or gray with shaded sides. All right, and then categorizing these Altocumulus clouds. There's, let's see, 4 different ones here, lots of different species. So you have Altocumulus stratiformis, so these flat, like bottom puffy clouds, or you have the lens-shaped clouds that form over just hilly areas. And then you have something like the Altocumulus castellanus, which basically is an indicator of instability. So those were the ones that lead to like the Cumulonimbus thunderstorm clouds. And then the stratiformis, those are the ones that you're going to see very frequently. They're very common. The lenticularis ones, I talked about the lens shape. Sometimes they're known as spaceship clouds because they form in the shape of a spaceship, or one would think that looks like a spaceship. And then you have these flocus clouds that are slightly smaller, but they're very ragged cloudlets. So we talked earlier about cloudlets. They're just smaller clouds that kind of form together in a group. They're very ragged when you look at them. All right. Altostratus Clouds. So these will evolve as a very thin layer that gradually thickens into a cirrostratus, and then is usually gray or blue, and they have very few features. So they're kind of hard to distinguish unless you know what you're looking for, but they're very large, mid-level sheets of very thin clouds. They're composed of water droplets and ice crystals, which usually form when that cirrostratus descends from a higher level. So they're thin enough in parts to allow you to see the sun kind of weakly through the clouds. We're starting to get to that level in the atmosphere. And then over a very large area, they're larger clouds, but typically they're featureless. So it's kind of hard to tell what they look like unless you're really looking for them and know what you're looking for. All right, so how do they form? These layers can sometimes contribute to the formation of what's called an optical effect, as like the corona, and sometimes they look like an iridescent cloud. So the sun cannot cast shadows when it's shining through these Altostratus clouds. So they're pretty thick, but they form ahead of a warm front usually. As that front passes, the altostratus layer kind of deepens, it bulks out, and it becomes these nimbostratus, which produce then that rain or snow at this point. So it's getting low enough into the atmosphere where it can come down and reach us onto the ground. But mostly they're featureless with little characters, what they call them, and not really classified into species because that's pretty much it. But they do have a lot of pattern-based varieties, and also just because they don't have like certain species, they look at the patterns that they form, and they also look at the thickness based. So they classify them based on the thickness and then also the patterns that they make. All right, and then Nimbostratus Clouds. So these are very dark gray, featureless layers of cloud, but they are thick enough to block out the sun, and oftentimes they do produce persistent rain. So we're starting to get to those clouds that they have precipitation and sometimes not dangerous, but heavy rains, often associated with a frontal system provided by a mid-latitude cyclone also as well. And then they're very least picturesque. I did not write this, but they are the least picturesque of all main cloud types. So I guess there's not much to them, but they do form through the deepening and thickening of an altostratus cloud. Oftentimes they're found along warm or what's called an occluded front, and they extend through the lower and mid layers of the troposphere, and they bring rain to the surface below. All right, so those were our medium clouds. So now we're going to go to my favorite, the low, because I like the thunderstorms. I like the dark, big, puffy clouds that we're going to see. So these are going to be our low cloud types. So back to our diagram that we had here. This is what we're looking at. So we're looking at the cumulus, the stratocumulus. These are going to be those thick cumulonimbus fluffy clouds that bring kind of hazardous weather conditions with them. All right, so these are the ones that, like when I think of a cloud, this is what I think of, these white, puffy, like cauliflower shaped things. So these clouds are very large. They're round masses of stratus clouds that form in either groups, lines, or waves. They are the most common type of clouds on Earth, and they're recognized really well because a lot of them are defined as having darker parts than other parts. They usually have gaps in between them, but they can also be joined together in a very large cloud. They can form from a layer of stratus clouds that have broken up, and they kind of all come back together at a lower atmosphere altitude, and they kind of band together. And then also they're indicators of change. Change in the weather, usually present near a warm, cold, or occluded front, but they can be in any types of weather. So they can be present pretty much anytime. And then also the Stratocumulus clouds are often mistaken for what's called our rain clouds. But in reality, it's really quite rare to get anything more than a light drizzle, if anything at all. All right, so categorizing these clouds. So there's quite a few of them. There's 4 of them. You have these things called Stratocumulus stratiformis, flat base layers of clouds with a few cracks in them. And then you also have these form when like rising cumulus clouds come up. Then you have some that are thicker, but they're more drizzly clouds. And then you have the Stratocumulus lenticularis, very rare. They're often spotted in only hilly locations, and they form when hills produce those atmospheric waves. So it's kind of neat to understand that clouds are produced because of different water vapors and ice crystals in the air, and also the altitude, but also thinking of like the terrain is also making these form. So that hilly terrain, that mountainous terrain, whenever I think of a place like Mount Kilimanjaro, you always see like the clouds formed around it in a picture. So it's not necessarily just the atmosphere, it is the altitude, it's the water, it's the dust particles in the air, but it's also the terrain. So very interesting to see how these things formed with each other. All right, so our stratus clouds, I feel like these are pretty common. I feel like I've heard about these a lot. Maybe you have too. They tend to be featureless, low altitude clouds that cover the sky in this like blanket of white or gray. And these clouds can actually persist for a very long period of time. They're very low lying type of cloud. They appear to the surface, and sometimes we will see them in the form of mist or fog. So in the mornings when you see that, that's what you're seeing, these stratus clouds. They form in a very calm, kind of a stable condition. They have a gentle breeze. They raise cool, moist air over colder air, or sometimes even you will see them over ocean surfaces because of the cool and the warmer airs when they switch with each other. And they're also accompanied by little to no rain, but it can produce a light drizzle, and it can also fall in the form of snow if it's cold enough. So if you don't like snow, blame the stratus clouds. All right, these two have two different types. The stratus nebulosus, featureless dark layer cloud that's capable of producing just kind of a drizzle, and then a stratus fractus, so a stratus layer which is starting to break up or dissipate, leading to a break in the cloud. All right, and then you have cumulus clouds. So these are fluffy. These are these white cauliflower shaped ones. They're the most common and distinctive type of cloud. I feel like I've said that a few times, but that's what the information I saw had. And then tops of the clouds are these like white tufts, and they're usually lit up by the sun. Although when you look at the base of the cloud, they're very dark. So I feel like in Nebraska, especially in Lincoln, we've had a lot of rainstorms in the morning or at night. And I feel like I've seen a lot of these clouds lately. So especially when you look at them, the top of it is fluffy, it's white, it's lit up by the sun, and then that base of that cloud is very dark. So these clouds, they're spotted sometimes in even fair weather conditions. Like I mentioned, the tops of the clouds are lit up by that sun, and then all cumulus clouds, they are formed because of convection. So as air is heated, the surface is lifted, and then it's cooled, and then the water vapor basically condenses, and then it produces a cloud. And then sometimes you will find these along coastlines. So that cumulus may form over land during the daylight hours because the sea will bring in that moist air, which is then warmed by the surface. And then overnight, this effect basically reverses. So as the sea becomes warmer, the air around it becomes cooler, and then those cumulus clouds will form over the ocean or over the sea. All right, so what weather is associated with these? Mostly cumulus indicates fair weather, but they often can pop up on bright sunny days. So if the conditions allow, the cumulus will grow into these like towering clouds that can produce showers. A lot of the times you will see there are four main different types of categories with these. So cumulus, humulus, which is funny to say. These are all wider than they are tall. They are often very numerous in the sky. And again, those fair weather conditions. But then you have things like the congestus. These are taller, but they look like long chimneys, and they can produce light showers. And then also like there's broken remnants of those cumulus clouds when they break up or they dissipate. And then you have the mediocris. These are usually wide than they are tall as the rest of them. And these are seen among a variety of other types of cumulus variations. So again, when you really look at it, you break them down into smaller categories. All right, Cumulonimbus Clouds. So these are like the king of clouds. So these clouds exist through the entire height of the troposphere, usually categorized by their like anvil-shaped top or their icy looking top. And they're kind of menacing looking clouds. They can be multi-level. So either the low or the mid-altitude levels, like we talked about, they exist in a very long height and they can extend through the entire troposphere. The base of the cloud is often flat, and then it has a very dark wall-like feature that hangs underneath. And these are so low that they can even be just a few hundred feet below the Earth's surface. So you can jump and touch them. But more commonly, these are known as thunderclouds. A lot of people call them that. They can produce very dangerous weather, such as lightning, hail, thunders. This is what you're going to be. So if you like thunderstorms, these are also ones that you should like. All right, so how do they form? So they're born through convection because they're those cumulus clouds that convection will form lots of different types. So they can form along cold fronts as a forced convection where the mild air is basically forced to rise because of that colder air that's pushing into it. They often grow from small clouds when there's a really hot surface. And then they get taller and taller basically until they present these huge powerhouse of a cloud. They store as much energy. So we have to think about these clouds. They're not just up in the atmosphere, but they store energy. Sometimes when they get very large, these very large powerhouse thunderclouds, they can store the same amount of energy as 10 A-bombs. So thinking about 10 atom bomb, 10 of those, they have that much energy in them. So clouds are very energy filled. These are associated with very extreme weather, heat, heavy torrential downpours, hailstorms, lightning, even tornadoes can form because of these clouds. All right, so like I mentioned, these individual cells, they usually dissipate with each other within an hour or so. They kind of start falling apart. They're very short-lived, heavy rain. They don't stick together very much, but they can, but they usually don't. But sometimes they're called multi-cell, or sometimes you might hear them called supercell storms. Basically, this is a lot of cumulonimbus clouds, and then the intense rainfall lasts longer. So the more clouds that you have together, the more energy there is, the more they produce. So the more lightning, the more thunder, the more hail, the rain, it tends to last a little bit longer. And then these have three distinct species, basically describing the shape of the head on the cloud. So the Calvus is going to be really puffy. These are at the top, they have not frozen to become ice crystals. And then you have the Capillatus. This is the top of the cloud is very fibrous, but relatively contained with each other. Not like the wispy clouds like we talked about at the very beginning. And then you have the incus. So these top of the cloud is anvil shaped, and this is the one that continues to grow over time. Okay, so those were like the main types of clouds. There are a few that I haven't mentioned that are kind of fun that I put them in like a special clouds. I didn't really know where else to put them. You might have seen some of these. They're kind of like a special circumstances clouds, and then we can go ahead and talk at the very end. So we talked earlier about these contrails, not chemtrails, contrails. They're made by flying high jet airplanes. So this is all of the water droplets that have been, the water vapor that's basically burned off in the atmosphere. And it's the exhaust of those jet planes. So these can form within a few wingspans of the aircraft. So if you've ever looked up into the air and seen these, you notice that it happens really quickly. So it happens within a few wingspans of the aircraft behind the exhaust, but they really dissipate quickly. So from the engine, because of the lack of water available or that water vapor in the atmosphere. And then they can provide a lot of good information about the layer of moisture in the sky. So they are important. A lot of people wonder, like, what's the point of them? But they provide a lot of useful information as far as how much water is in the sky or that atmosphere and what altitude as well. All right, these are my favorite types of clouds. They're called Nimbostratus Clouds. There's also a name that I'm not going to use on here, but you might have heard of it before. So these clouds are actually Altocumulus, they're cirrus, they're Cumulonimbus. They can be lots of different types of clouds, but what you will notice is they have these very distinctive, like pouch-like shapes that form at the bottom. So with Latin, we talk a lot about like it means something. So the mammatus usually is the Latin word for mama or breast. So it looks like a breast. So thinking about mammals, and they feed off of the milk from their mom. So that's where they get the names. These pouches then are created when cold air in the clouds sinks down towards the earth, creating those little pouch-like things that we see. This means that severe weather could be on the way. They're sometimes associated with convection, severe weather. That's when I've seen them. Also, they're really picturesque, and if you take pictures, they look really interesting too. All right, and then you have these like orographic clouds. These are ones that are the next two that I'm going to talk about are really specific to the type of terrain. So again, those mountains or the hills, they basically force the air to move over or around them, which creates these interesting shaped clouds. So they develop in a response to the forced uplifting of air by the terrain. They also can form by the sea breezes and often appear as lines where two air masses will meet together. And it is an early sign that the conditions might be right to form, for instance, like an afternoon thunderstorm in that area. So again, these are clouds that are specifically shaped because of the terrain that they are in. All right, and then you have these lenticular clouds. These are ones that are simply sometimes called like flying saucer clouds, but they're shaped like lenses. Or if you look up these on Google, there were some really cool almond-like shaped clouds, like literally look like an almond, but they're stationary clouds. They form mostly in the troposphere, typically in like a parallel alignment to the wind direction. So wind is a huge factor when we talk about these types of clouds. They're often seen in the winter or the spring because that's when the winds are the strongest. And I think we can all agree with that here in Nebraska. And they also get their name from these hilly terrains. Or just the way the air is rising over this flat terrain. So it almost looks kind of menacing, like a tornado-shaped cloud, but it doesn't necessarily mean that severe weather is there. It's just basically the wind or where these air masses will meet together. All right, so that was it. That was a lot of like deep information. It was a lot of like cumulo and stratus and a lot of different types of suffixes and prefixes. So hopefully we didn't get too bogged down, but it is the science of, so we dove a little bit deeper today. I do want to let everybody know that this was our very last summer series. We've gone 6 weeks now, so we won't have another science of until October. Our first one will be about rattlesnakes. So October is Nebraska Reptile Month, so we're going to like hit that hard. And then there is none on October 26th. So some of you I think might have been registered. We have a really big event coming up that day that I just can't get here, do this until 4 and then head to my event at 4. So we're going to cancel it and then just tack it on to the very end. So it was supposed to be on October 26th, the science of venom and poison. We're going to just move that down to November 16th and tack it on at the end instead. If you did register for that, you should have gotten an email saying that the date was changed. But same time, 3 to 4 p.m., that will not change at all. And then if you want more, we have lots of different YouTube videos. So in our emails that I will send you, I do ask for everyone to fill out an evaluation if you would like to, and we will send you some swag. So thank you for doing that. We do ask, like, what do you want to see? And a lot of people have said, I'd like to see the science of this or this or this. Well, some of them might have been done already and are on our YouTube channel. So check it out under the playlist Science of. We also have our wildlife education Facebook and our Instagram page if you like social media, just different information, fun facts, resources on there as well. And then our Nebraska Wildlife Education website on our main Game and Parks page as well is on there. And then thanks everyone. I can answer some questions or try to answer some questions. So thanks. We will see you in October if you would like to come back, which I hope you will. I'm going to stop sharing my screen here and we can check out. Looking forward to the fall series. Thanks, Monica. Thank you. I hope you learned a little bit more about clouds. And so the objective here and what I wanted people to take away is looking more into what do they mean? So thinking more about all these different elements kind of surrounding together and making different types of clouds. So, all right. So thanks, everyone. How do roll clouds form? I didn't come across anything called a roll cloud, but that's a good question. I'm not sure what that means. So there might be like a different term used to describe them, but I didn't come across that when I was researching. So I can look into that and let people know. I will write it down. All right. All right. Thank you, everyone. I hope you had a good introduction to clouds, and we will see you in October. So October 5th, 3 to 4 p.m. Thank you. Have a great weekend, everyone.